Hello everyone. This will be homework 5. Hence, I'm going to share my screen again. 3, 2, 1. Yes, you should see it now. So I'm sharing my screen. We're going into homework 5 at this point. And looking at question 1. So this is intervals and things. This doesn't tell me the name of things. So we need to remember some things here. This is less than. This one's greater than. If you have half the equal sign underneath, it's less than or equal to. If you have the less than, half the equal sign under the greater than, then it's greater than or equal to. Equal to. All right. So for number 1, they want us to graph the inequality, and because it's not equal sign, it's an inequality, below on a number line. So we're going to grab a number line. 4 is our number we're looking at. There's no equal sign, so 4 is open. We also want to remember that open is a circle or a parenthesis, and closed is a solid dot or brackets, depending on how they want us to do it, and they'll tell you usually in the ALEKS itself. But we'll use the open circle right now. And that says it's less than, so less than 4 is everything on the left side of 4. So we've graphed that. All right, next one. Graph the compound inequality. Now it's called a compound inequality because it's got the word or in there. Could have the word and in there. Compound inequality is also one of those down there. So that's a compound inequality as well. Okay. So we're looking at -8. And we see that we have an equal with the -8. So that's going to be a solid dot. And we see that it's less than the -8. So it's everything to the left. Or greater than 7. So 7 doesn't have the equal, so it's open. And it's everything to the right, because that's greater than. All right. I like graphing these things. These are fun. All right, now we're going to look at the fact we have, okay, x, and that line there means such that. I can't write. Such that. So we have the set, and the set is represented by curly braces. Such that x such that x is between -4 and -1, but it's including -1 because of the equal sign, but not including the -4. Notice they want us to graph it, but then they also want us to use the interval notation, and that's where the parentheses and the brackets come in. So we see we're open on -4. We're closed on -1, and the x is between those two. We know if it's open, it's going to be either the open bracket, open parenthesis, or closed parenthesis. So we're starting, so it's open at -4, comma, we're going to -1, but -1 is closed. The brackets or parentheses will always face towards the inside. Okay? So that is our interval notation. You ready? Number 4. B and C are sets of real numbers, no imaginary things going on, defined as follows. B is the set y such that y is less than or equal to 1. C is the set y such that y is greater than 5. We want to write B union, this is union, C, and B intersection C. If the set is empty, we'll write the empty set, which is a circle with a line through it. That's the empty set. It's a circle with a line through it. It's not a zero. All right, so remember some things. Union is going to be the U, of course. U for union. They didn't know what to call the other one, so they just turned the U upside down. All right, so union is, I like to think of it as everything. And intersection that's the upside down U. I like to think that of what they have in common. Sometimes you can look at the overlap. All right, what they have in common are the overlap. So let's do the union first, because that's always easier. So B union C. The first thing I want to do is I want to graph these two. If I graph B, 1 is here, it's included, and it's everything less than. If I graph C, in relation to that 1, 5's probably over here. 5 is open, and it's everything greater than. So B union C is everything you see. You've got the top graph, which is negative infinity to 1. You get the bottom graph, which is 5 to infinity. So you're unioning your union together, B and C. So when you put them together, you have the negative infinity to 1 union the 5 to infinity. So that is our union. When we look at our intersection, we look at what they have in common. Well, or where it overlaps. Well, from 1 back, there's no overlap there. 5 forward, there's no overlap there. There's nothing between 1 and 5. So in this case, there is no intersection. There is no common ground. There is no overlap. So we draw that circle with a line through it, and that means it's the empty set. There is no intersection for these two sets. Alrighty. Moving right along, question 5 of 15. We're going to translate the sentence into an inequality. Use the variable x for the unknown number. All right. All we got to do is translate the sentence. We don't have to solve it, okay? So take it piece by piece like we were doing the other word problems. Sometimes you read it through first and pick out a few things you recognize, and then read it through again, see if you can put it together. So sum, that means plus. The sum of a number, we don't know what the number is, so that's x, times 10 and 29 is at most. Now remember we said the variable verbs were like equal signs? Well, make sure there's not something following the is, because is at most is less than or equal to. Because you can't get any higher than most. So it's going to be that number, in this case 30, and everything less. So let's see if we can make this. The sum of a number times 10. So we're taking a number times 10, that would be 10x, and we're summing that, adding to 29 to get at most less than or equal to 30. And that is what they are looking for. They're just looking for the translation. They didn't ask us to find the actual answer. Just said translate. Didn't say solve. Alrighty. Now we want to write an inequality for the graph shown below. We're going to use x as our variable. Be careful, make sure you always use x. Or what do they tell you to use? 4 we notice is open. Now they want an inequality. They don't want an interval. Inequality, remember, they want this either to be less than, greater than, less than or equal to, greater than or equal to. All right. But we see that we got an arrow on the end of this. All right. So it's going forever that way. So that means x is going to the right. So x is greater than something because it's open. No equals. It's greater than the negative 4. So that's what they're looking for there. Question 7. Again, you can rewind this, you can view it, you can pause it. Questions, put them in D2L. Discussion, Alex homework questions. Let's earn some points in there for participation. Okay, we're going to write the following as an inequality. I think you're trying to figure out what homework 5 is all about, huh? 9 is greater than x. All right, well, we can just write that down. 9 greater than x, and 4 is less than or equal to x. 4 is less than or equal to x. All right, well, now they tell me, though, they only want me to use x once in my inequality. I've used x twice. I don't know about you, but I need to see things visually. So 9 greater than x. That can be rewritten. X is less than 9. Okay. Or you can think about it as 9 bigger than x. 9's bigger than all the x's. The other equation is a 4. But if 4 is less than or equal to x, I mean x is greater than or equal to 4. So that's 4 and everything bigger. Is that right? Yeah, because 4 is less than or equal to everything that x is, and x is all the stuff over here. And means intersection. All right, so let me do the little hint over here. And is intersection. Or is union. Okay? Intersections where they overlap. Well, from 4 to 9, they overlap, but notice 9 is open and 4 is closed. What am I doing? I'm writing an inequality, not an interval. The interval will be simple, right? 4 to 9. Well, it's the same idea. 4, x is in the middle, and you're going to an open 9. So that's the inequality. The inequality puts the x in there with the inequality signs. The interval has everything understood based on the parenthesis or the bracket. All right, so again, we're going to write another inequality, in this case a compound one, for the graph shown below. It's the same idea. We want to use x for our variable. So we've got an endpoint on both ends. X is going to be in the middle then. On the left-hand side, you've got 3, and it's open. So 3 is less than all the x's that are over here on the right, but 5 is greater than or equal to all the x's that are over here. So 3 is less than x, less than or equal to 5, because x is to the left. Alrighty, math is our friend. Now we want to solve the inequalities. Now there's only one thing you need to do when you solve inequalities, is pretend they're equalities. Alright? Just like equality, equations, how's that? Except, and yep, I'm screaming and hollering and everything, except when you multiply or divide by a negative. When that happens, change the inequality sign. So less thans will become greater thans, etc. Just turn it around. So less thans would become greater thans would become less thans, etc. I think we're going to get to see it in this one, so you're okay. So simplify as much as possible always. When it comes to inequalities, I just like to leave my variable on the left. Even though it's going to be a negative, it's going to make life difficult. Turning them around like I had to do in question 7 here makes me think a little harder. I don't like to think hard, so here we go. We're going to subtract this particular 6 from both sides. That gives us a negative 6x less than or equal to 30. So we're going to divide by that negative 6. But at that point, red lights should be going off in your head. You're dividing by that negative. So that means x is going to be greater than or equal to negative 5. You just turn the equality sign around. Anybody wants to see the reason for that? Post a question in D2L discussion, and I will answer. All right. We have another inequality we want to solve for. I'm going to multiply everything by the LCD of 4. I'm going to use a positive 4. I'm not going to make anything crazy here. So I multiply that times 4. Multiply everything by 4. There we go. I'll come up here. Might need more room. 16 is greater than negative 3w minus 8. Okay. Now remember I said I like to keep my variables on the left. So I'm going to add this 3w to both sides because I want my variables on the left when I'm dealing with inequalities. It's just who I am. If you don't mind them on the right and it all works out okay for you, go for it. It doesn't matter. I just prefer to have them on the left because I'm going to read this thing left to right when I finish, and it's easier for me reading left to right. Okay, subtract the 16s. We get 3w is greater than negative 24. Divide by 3, so it's a positive 3. Everything's okay. It's going to be negative 8. So w is greater than negative 8. All right, so they get a little more exciting, just like they do with the equalities. We're going to distribute, just like we do with equality. Again, remembering in your head, if you divide by a negative or multiply by a negative, you got issues. So, I don't even know where to start this thing. I guess right here. 7v minus 19 is greater than negative 4 plus 10v. Again, I like my variables on the left, so I'm going to subtract the 10v. It's just who I am. So that's going to be a negative 3v minus 19. You know what? Let's do all this at once. So I'm going to add the 19. Right? That's going to go away. That goes away. So we're left with variables on the left, like I like with my inequalities. But when we divide by that negative 3, well, red lights should be going off, right? So that tells me v is less than a negative 5. Alrighty, so for question 12, it's the same idea as it was with the equations. If you get a true answer at the end, the answer is all reals. If you get a false answer, it's no solution. Or you may just actually get a solution answer. Alright, so let's see what we get. We're going to go ahead and distribute the 3 and the 5. So that's negative 3u minus 21 plus 39 is greater than 10 minus 5u. Combine like terms. Negative 3u plus 18 is greater than 10 minus 5u. Again, for inequalities, I just like to get all my variables on the left. So that's going to go away. So that means I'll subtract my 18. So that'll go away. 2u is greater than negative 8. Divide by a 2. And u is greater than negative 4. So I actually got an answer on that one. It's going to be this one. U is greater than negative 4. All right, different problem, so I'll go ahead and change the colors. Distribute the 5. All right, so it's going to be 15 v plus 20 is less than or equal to 15 v plus 24. I like to move my variables left, like I said, but when I do, you might notice what happens. Those go away. 20 less than or equal to 24. That's a true statement. So therefore, it is all real numbers. 20 is indeed less than 24. Remember, it's less than or equal to 24. Either one can be true. You don't have to have both true. In fact, you can't have both true. It can't be less than and equal to with what we know right now. All right, so we got another one. We want to solve it and then graph it. Okay, so we got a compound inequality. Notice the x is in the middle. When the x is in the middle of a three-piece compound inequality, you want to keep x in the middle. So you get minus 4 less than 2x minus 2 less than 8. So you're going to keep x in the middle. We're going to add 2, but what if you do it to the middle? You got to do it to the right. If you've done it to the middle and right, you've got to do it to the left. So everybody's got to have the same thing done to them. Equations have a left and a right. This thing has a left, right, and middle. Still got to do it, same thing to everything, just like an equation. All right, so I'll be dividing by a positive 2. So all my signs stay the same. I'm okay. I'll leave my x in the middle. They're both less thans. I can do the 5 better. Okay, so it's negative 1 is less than x is less than 5. So we want to graph it. So we're open at negative 1. We're open at 5. And it's everything in between because x is in the middle. Isn't that exciting? Math is our friend. 2 more for homework 5. Yay! Okay, so we want to solve this compound inequality. Notice we have an and. We're just going to remember that's the intersection, right? Oops, wait a minute. Do this one in blue. All right, and intersection. All right, so what you want to do is you want to solve both of these. Go ahead and subtract that 5. Go ahead and subtract that 4. Going to save a space here. So as 3w is greater than a negative 3, and 2w is greater than or equal to 8, divide by 3, w is greater than negative 1, and w is greater than or equal to 4. Only way I know to do this is graph each one. So I've got negative 1 here. Greater than is open, and it's everything to the right. That's this one. This one. 4 would be around here somewhere. It's closed. And it's also everything to the right. It's greater than or equal to. We want the intersection where they overlap. There's no overlap down here. There's no overlap. Nothing. Right? No overlap happening down here. The overlap is happening here. Write the solution in interval notation. So the overlap is happening from the closed 4 to infinity. That's where our overlap is happening. That's what they have in common. All right, those same side ones can be exciting. So, what's all this for? Well, hello, we got a word problem. Bill is going to rent a truck for 1 day. 1 day. So we don't got to worry about multiple days. 1 day. He has 2 companies he can choose from. They have the following prices. Company A charges an initial fee of 60 and, that's plus, right? 60 cents for every mile driven. So we can say that Company A charges, that's the equal sign, right? That's the equals. $60 plus 60 cents. I'm going to do it that way. Per mile. M for mile? Yeah, look, it says use M for miles. What do you know? All right. Company B charges $100 initial fee plus and additional 10 cents for every mile. So Company B is 100 plus 10 cents per mile. I changed my cents into dollars because I wanted to put them all in the same units, right? You didn't want to put the 60 and 10 there. Right. The question is, for what mileages will Company A charge less than... Oops, that's not very good. Eraser there. All right. That's a plus sign. Less than Company B. So we want A less than Company B. So we know what A is. 60 plus 0.60 M less than, and it said to use M for miles, 100 plus 0.10 M. And notice it wants the answer as an inequality. So we can do that. All we gotta do is solve it down. Then again, I like to move all my variables left for inequalities, and that takes my constants right then. Now we're driving miles, right? So we should get a positive answer. Shouldn't be any negative miles. All right, so that goes away and that goes away. This is going to be 0.50 M less than 40. So that means M is less than 80 miles. So Company A will charge less than Company B as long as you keep it less than 80 miles. You go over 80 miles, you're better off with Company B. That concludes homework 5's hints. And I'm turning off the recording.